Hi everyone, welcome to Graphical Transformation Art Part 7. Before watching this video, make sure that you have watched the Part 1 to Part 5. In this video, we are learning some JEE questions based on graph. Some simple questions I have taken in this session here. So with the help of graph, today I am discussing around three concepts here. One is concept of increasing and decreasing function. So other is a concept of maxima and minima. And next is the concept of continuity and what here differentiability. Before going into the question here, let me summarize what do you mean by increasing, decreasing, maximum, minima and continuity and differentiability. These are the maximum weightage are there in application of derivative of class 12 here. So there they have one individual topic itself here. Okay, what do you mean by increasing function here? Check the graph behavior right from left to right here. Right from left to right here. If your graph slope is continuously positive, then we say the function is increasing here. If the slope of graph is always positive, such kind of graph is increasing function here. If the slope of graph is always negative, continuously it is negative, such kind of function we say decreasing function here. Then what is a maximum value here? Maximum or a minimum value? The highest value, say for example sine function. The sine function highest value is what here? +1. The lowest value is what here? -1. The maximum value of sine function is +1. The minimum value is what here? -1. Maximum or minimum nothing but f of x value, or you can say simply range he is asking. Okay, and continuity, what do you mean by continuity? If any function you can draw without lifting your pen, then such kind of function we call continuous function here. So then how to check differentiability here? See here, the function is not differentiable at a sharp curve here, if corner point as well as what here the edge point here. So your function is not differentiable at corner point and edge point. So in such case your function is not differentiable. Why? The reason is very simple here. At a corner point it is possible for you to draw more than one tangent here. So derivative should be unique here. Derivative nothing but tangent. Tangent should be what here? Unique. So at corner point it's possible for you to get more than one tangent. Because of that your curve is not differentiable. Without wasting much. Lot many students will get confused in terms of increasing and decreasing function here. This is very important topic in physics also. Increasing function nothing but it's having a positive slope. Decreasing nothing but what here? Negative slope here. You think these graphs like what here? Mountain and valley. If you are feeling like you are climbing up or you are going up here, definitely increasing function. If you are feeling like we are going down, so decreasing function, that's all. So whenever you are checking increasing and decreasing function, you check its behavior right from left to right here. Left to right you check here. If you feel like you are climbing up, positive slope, increasing function. If you feel like you are getting down, so negative slope, decreasing function. You check from here to here. Say from left to right here, this curve. From minus infinity to, say it's minus infinity to what here? From this point here. You are feeling like you are going up. So positive slope, hence this guy is what here? Increasing function. Say this guy is, say for example x equal to -2. From -2 to -2, say this guy is what here? 1. From -2 to 1 you are feeling like, so you are getting down here, decreasing function here. Okay, so this guy is what decreasing. Again from this 1 to infinity you are feeling like you are going up. So if it's a mountain you're going up here, definitely this is what here? Increasing. So nothing but from minus infinity to 2 it is what here? So increasing function. From 2 to 1 it is what here? Decreasing. From 1 to infinity this guy is what here? Increasing function. That's it, right? So take this example here. From left to right here, if you think it's a valley and mountain here, okay, from left to right you are thinking from here to here, this function is what here? So decreasing function, decreasing, say this guy is what here? Again once again -2, right? So this is 1. Say from -2 to 1, from here to here. So you are feeling like you are climbing up the mountain. Definitely this is what here? Increasing. From this 1 to minus infinity, 1 to what here? This infinity, right? So from 1 to infinity, sorry, plus infinity, 1 to infinity, this guy is what here? Decreasing. From here to here, increasing. And here it is what here? Decreasing. That's all. Decreasing, increasing, and what here? Decreasing. You check this curve here. So from minus infinity to what here? X, this is value of x, okay? So minus infinity 0. So you are feeling like you are getting down, right? Decreasing. From 0 to infinity you are feeling like you are so climbing up, right? It's what here? Increasing. This is what here? Decreasing. From minus infinity to 0, decreasing function. 0 to infinity, increasing. So take this curve here. So check the behavior right from left to right here. So right to left continuously. Are you climbing up or down here? Definitely you are going up, no? So because of that this function is continuously increasing right from minus infinity to plus infinity. Okay, let us start now. Start now. Question number 1. For every value of x, the function f of x is. Let me draw the basic sketch of f of e raised to x curve here. Okay. So this is the curve of e raised to x. Right. Okay. Right. So he's asking question on increasing or decreasing here. Check from the graph here. See here. Your graph is continuously increasing, definitely, because your slope is always what here positive. If the slope is always positive or continuously your slope is positive, definitely this function is what here increasing. So either you check or increasing, decreasing, you check from left to right here. Left to right, this curve is continuously rising. Because of that, so option number A is correct. This guy is what here increasing function. Question number 2. The function f of x is equal to x square. So sketch the curve here. F of x equal to x square. It's a smiley function we are saying. The most beloved function. Okay. See here. So in both the side, the function is what here running towards infinity here. It's always going, so all the leading coefficients are positive. So minus infinity plus infinity. This is, see the behavior. Check the behavior. I need to check increasing decreasing, right? Okay. Minus infinity plus infinity. 0. See. The slope of this curve right from minus infinity to 0. So minus infinity 0. The slope is what here negative. The slope is negative. So because of that, from minus infinity to 0, this function is what here decreasing. Afterwards, from 0 to infinity, you check the slope of the curve here. Your slope of the curve is always what here positive. So because of that, in the interval of 0 to infinity, the function is what here increasing. Hence option number C is correct. Remember, so minus infinity plus infinity, this function is neither increasing nor decreasing. From minus infinity to 0, so check the behavior. You simply feel it here, right? From left to right, it's coming down, decreasing. From 0 to infinity, it's going up, it's increasing. That's all. So the answer is what here? Option number C, 0 to infinity. So question number 3. For all real x, the increasing function is. In the given option here, which option is increasing function is asking. Question number 1, x raised to minus 1, nothing but 1 by x curve here. So one part is here, other part is here. Definitely it is neither increasing nor decreasing. Option number A is not there. Option number B, x square nothing but once again a smiley curve. It's neither increasing nor decreasing in the real number interval here, because half is increasing, half part is what here decreasing. He's asking what here? Continuous increasing function. Hence option number B is also not there. Then option number C, x cube, y is equal to x cube. So y is equal to x, this is a sketch of y is equal to x cube. Okay, now you check its behavior right from left to right here. So from left to right, see it's the slope. Is it positive? Yes, continuously it is slope is what here positive. So it is rising always, all time it is rising. Because of that, this function is what here increasing. Remember student here, whenever f of x is equal to x raised to 2n plus 1 curves, all odd polynomial functions are always increasing function, and the range is always what here? Real number. Remember this concept here. And option number D, x raised to 4. X raised to 4 curve is like x square only. Okay, so it's partially increasing, partially what here decreasing. Minus infinity 0 decreasing, 0 to infinity what here increasing. So among the option here, continuous increasing function is what here? X cube. Okay. Question number 4, the maximum and the minimum value of f of x is equal to sine 2x plus 5. He has given sine 2x here. What is the difference between sine x curve and sine 2x curve here? Whenever sine 2x curve comes here, if your curve is going to compress or compress about what here? X axis. Okay. So I will not use graph here, directly I will solve here. What is the range of sine 2x here? So minus 1 to 1, minus, it's a range of sine 2x. Okay. So if plus 5 is added, according to our graph concept, if the plus 5 is added outside here, initially your curve is, sine curve is running from minus 1 to what here? Minus 1 to plus 1, right? So if your plus 5 is added, it moves 5 units upwards towards what here? Positive y-axis. So you simply add it here, no? So plus 1 you add it here. The minimum value is minus 1 plus 5. So 4. Max value plus 1 plus 5, nothing but what here? 6. Okay, your graph will going to drag 5 units what here upside. Because of that, max value is 6, min value is 4. Hence option number A is correct. It's concept of maxima or minima. Look at question number 5. It's very interesting. The function represented by the following graph. I'm requesting all the students, those who are watching this guy, so kindly do not forward the video. So whenever you are watching, so else you are missing some important concept here. Okay, right here, the function represented by the following graph. He's asking about continuity. Look at the graph here. Can I draw this graph without lifting my pen? Definitely. hence it is continuous. Okay. So do you find any sharp edge here or corner point? Yes, it's there. At x equal to what here? 1. At x equal to 1, it is not differentiable. So, and it is what here? Continuous. Hence option is what here? Continuous but not differentiable at x equal to 1. That's it. Okay. So now here's a time for you to announce. The fastest finger is Miss Ankita B for Graphing is an Art Part 6. So I wish you all the best for your next studies. I'm requesting all the students, those who are watching this video, kindly do comment in the YouTube comment box. It may be first or last. Your sincere effort matters a lot for me. Okay, here I will be giving some question for you. Question number 1. The max and min value of f of x equal to cos 2x plus 4. Okay, and write the interval in which f of x equal to sin x is increasing in the interval 0 to 2 pi. Sketch it and observe. So what are all the interval in which your function is increasing in the range of 0 to 2 pi. We shall see with one more beautiful video in the next session. Until then, bye bye, take care and happy learning.